Hey guys, Mr. Mailhot here. I figured out how to do picture-in-picture, so this is kind of exciting. Let's see how this goes. Hopefully everything's going well. Do your best today. We're going to be talking about graphs of rational functions. We're still dealing with functions or polynomials, but rational, aka fractions, okay? So these can be intimidating, but I guarantee you, if you stick with it, they're not that bad at all. Not at all. Now, as we go, if you think of a question or something pops up that's hard, please take a second to write it down so we can talk about it when I get back, okay? Jot a couple notes down in here or draw a picture, and we'll get to it, okay? Here we go. Now, these are kind of like guided notes, so you should follow along on this worksheet, but if you need to take notes on some extra paper, I've got some blank paper here that I'm going to use just to jot a couple other things down. That'd be a good idea, too. So far, and basically most of your math career so far, you've only been talking about continuous graphs, aka ones that you can put your pencil down and not have to pick it up in order to complete the graph. Right? Continuous. All linears are continuous. They go on forever without stopping. Discontinuous kind of means two things. Discontinuous. Actually, and if I didn't mention, pause the video at any time, okay? Pause it at any time to jot down what you need and then pick back up. Or rewind, shoot, go slow-mo, I don't care. Discontinuous. Graphically, that means you have to pick up your pencil. So if I went up here and then, something stopped and made me jump down here to continue, and there's a gap, discontinuous. Or like we'll see here in a bit, things that won't ever cross the x-axis. And then there's another part down here that fits the other half of the graph. I had to pick my pencil up to graph those. We're going to talk about that as well. Discontinuous. Algebraically, discontinuous means how do I say this? Values make the function undefined. Values make the function undefined. There's stuff that does not work. Undefined, you'll probably remember, means this. If you divide by 0, so like x over 0, 3 over 0, 10 over 0, happy face over 0, 0 over 0? We'll save that for another day, okay? 0 is a weird case. But if you divide by 0, you're talking undefined. So we're looking for things that make functions undefined. From a graph, sometimes we have to create them. So let's look at an example here. A. This line, we're going to come up with the equation for this line. It's got a hole right here at -2, if you see that right at -2. This is called a discontinuity. Discontinuity. Let's write it down. Discontinuity. It's a discontinuity. A thing that is a hole in our graph. If we ignored it for a second, though, you might think that this equation is just y equals 1 because it goes through 1 on the y-axis. I mean, we're almost there, but since there's a hole, that means something made it undefined. Now, we just said undefined means divide by 0. I don't see any divided by anything here. We can create it. We're mathematicians. We can do anything we want. Let's put something under a fraction that would make it undefined at that value. I think if we put an x plus 1. If we put a -1 in there, right where the hole is, if we put a -1 right there, that would become undefined. Now we can't just put it on the bottom. That's ridiculous. We still have to have this shape of a graph, right? Equal to 1. So top and bottom. Kind of like we've done before. Remember, these are like your big, in this case, super ugly ones. Right? This is a 1, and yes, you would be right if you're thinking you could cancel those out. But just because we canceled them out doesn't mean they went away altogether. In our graph, it creates a hole because if I plugged in -1, we would have undefined. Everything else is okay. Let's try another one that's a little trickier. C. A to C, what the heck? Okay. This is a quadratic. You see the two roots at -2 and 2, meaning the factors would be x plus 2 from this first one at -2, and x minus 2 from the second one at +2. You see a hole lined up with -1 right here. That's a discontinuity right there. Something weird's going on. Something became undefined right there. Well, same as we did up here. We have to make something that makes it become undefined. So that was at -1, just like actually look up here. X plus 1, if you plugged in a -1 here, that would become undefined. It would become a 0 on the bottom. And you don't want to divide by 0. That's not good. Now, just like before, we also have to have one up top. They would cancel each other out if we simplified, but it still creates a hole right there. Let's try one more. E. Looks like the same shape, doesn't it? X plus 2, x minus 2. It has the same roots, except, uh-oh, there's a discontinuity right there at 2. And there's that one up down at -1 also. It lines up with -1 on the x-axis. So, like before, we'd have to have an x plus 1, just like before, x plus 1, to create this hole right here, this discontinuity right here. But there's also one here at +2. Now, what could we put down here? Think for a second. I'm going to pause. What could we put down here on the bottom of our fraction that we could plug in a 2 and make it become 0? Hopefully you thought of it. X minus 2. Right? If you plugged in a 2 here, that would become 0 and then make it undefined. Now, just like before, if we're going to put another x minus 2 on the bottom, yes, there's already one up top. But if we're going to add another one onto there, you got to put another one up top as well. Yes, they would cancel out. We could simplify a little bit to have this be our final equation like before, like to get our shape, but these create two holes at those two values. Let's do it without a graph. Write an equation for a function that is a horizontal line, so kind of like the first one we just did. Horizontal line at y equals 3, but a hole at x equals -2. So graphically, we're going through 1, 2, 3, like that, but then there's a hole at -2. So y equals 3 is the basic part of it, but there's a hole at -2. Well, what could we put on the bottom of a fraction that would make it undefined at -2? Well, shoot, an x plus 2. If we put it on the bottom, also got to put it on the top. And there we go. Yes, this simplifies, but there's still a hole at x equals -2, like they wanted us to have. X equals -2 would make that equal to 0, make it undefined. Number 2. Write an equation for a graph that looks like a parabola, so x squared, but holes at 1 and 3. So we've got a parabola, something like this, but a hole at 1 and a hole at 3 up here. We could come up with tons. Like the most simple one would be y equals x squared, right? That's a parabola, but let's give it a couple holes at x equals 1, meaning x minus 1, and x equals 3, meaning x minus 3. And we got to have the same top and bottom. They would cancel out if we simplified, but they still have a hole or two holes two discontinuities at 1 and 3, like we were asked. Now you could make this more complicated. You could have this be something crazy right here instead of just x squared. But that's the simplest one, so let's stick with that. All right. I think we'll pause there. Take a second to collect your thoughts. I think I'll post another video that talks about holes in graphs. So maybe watch that for a second, and then we'll come back and we'll keep going a little bit more, okay? Keep it working, guys. Nice job.